Hey everybody who couldn't make the Teams meeting. This is a very quick lesson that we're going to call the 7.1 lesson, Characteristics of Exponential Functions. And I'm actually going to start by getting you to take a look at a Desmos page. And usually when we graph something, where we graph an xy coordinate, x of course is the horizontal axis. What if x is the exponent? You'll see that I have the graph here of y equals some number to the power of x. Well, right now that number I have it set to be 1. And we just talked about this. 1 to the power of anything is still 1. Hence, this is a horizontal line. 1 to the power of a billion is still 1. So, this is not a very interesting graph. Let's change it to when that base is 2. So this is the graph of y equals 2 to the power of x. And check out this funky curve. Why does it behave this way? Well, let's take a look at your notebook. So we're going to go past the first page here. And we're going to go to sketching the graph of f of x is equal to 2 to the power of x. So all right, what happens when x is 0? Well, 2 to the power of 0 is 1. Anything except for 0 to the power of 0 is 1. What happens when x is 1? Well, then I'd get 2. What happens when x is 2? Well, then I'd get 4. What happens when x is 3? Well, then I'd get 8. 4 would be 16. But what if we were going the other way? What if x is negative 1? So I'm asking you, what is 2 to the negative 1? And remember, we looked at this the other day, that does not make negative 2. It makes a reciprocal. It makes 1/2. What happens when x is negative 2? I get a quarter. What happens when x is negative 3? I get 1/8. Okay, I think you can see what's happening here. We will, for sure, have this point here, right? Because we're going through, I'm going to have to put this down a bit. There we go. So we have the point 0, 1. We have the point 1, 2. 2 becomes 4. 3 is already past the screen. I can't see that. So we are swooping upwards very quickly. Oh, I missed the dot. Make it bigger. Swooping upwards very quickly. Now, what's happening as I go to the left? Well, at 1, I get a half. Then I get a half of a half at a quarter. Then I get a half of a half of a half at an eighth. So I'm actually trending that way, which is what we saw on my Desmos screen. So let's go to my Desmos screen. There we go. And as you can see, that's exactly what we got with Desmos. And now, will this line ever actually touch the x-axis? The answer is no, and we have a name for that. When a curve is approaching a value, but it doesn't actually touch it. On a graph, we call that, it begins with the letter A. Anybody remember what that word is? That's an asymptote. So if you remember that from grade 11, that's going to be very important to the way these graphs look here in grade 12. All right, let's go back to the notes. This is very clumsy to have to do this, but there we go. We're back in the notes. Okay, note the base of this function is 2. The function is increasing. As I go to the right, it's getting bigger. It passes through 0, 1. It has a horizontal asymptote at y equals 0. Remember, y equals 0 is, of course, that is the x-axis, right? Because y can't be negative. Think about why that is. We talked about that the other day. There's no number of 2's you can times together and get a negative answer. You can't times any number of positives and ever get a negative. So there's no possible exponent I can put on the base of 2 that'll give me a negative answer. So that's why this line here can never actually cross the x-axis. Okay, the domain is infinity left and right. The range is it can't go below 0. Notice it can't even touch 0, hence curved bracket, and it goes to infinity. So that's the scoop on this graph. Go back now, and notice this is the only 2 types of shapes exponential function graphs can have. If you have some base to the power of x where that x is 1 or bigger, actually bigger than 1. If it's bigger than 1, you're going to get this curve upwards. So this lovely exponential curve here. If you have a base that is between 0 and 1, a fraction, it's going to curve downward like that. Now, let's think about why that is. Suppose I had, for example, something like y equals 1/2 to the power of x. Oops, I didn't mean to write a 2 there. I meant to write an x. That's better. Think about what that means. Well, what if x is 1? Well, then I get a half. What if x is 2? Well, then I get a quarter, then an eighth, then a 16th, etc. Notice I'm getting smaller, right? A half of a half of a half. I'm making smaller numbers every time I do that. So that's why it's going downward like that. Okay? So there's some stats on that. The one on the left is an increasing function, right? The one on the right is a decreasing function. But notice, all of their other stats are pretty much the same. Where do you see these types of graphs? You see them in biology all the time. When they talk about, we're in our current pandemic here. Oh, hang on a sec. I'm going to pause the video for a second here. All right, and we're back. Okay, so where was we? We were looking at, okay, can everybody just put down the test for a second? Okay, so when we're talking about the fact that we're in a pandemic, of course, they talk about wanting to flatten the curve. You know what, that's what they're talking about. They're trying to make this exponential growth curve flatter. I mean, they know it's going to keep increasing, but if it's increasing at a very sharp rate like that, well, that's going to put an enormous strain on the healthcare system, so that's why it's a matter of flattening the curve. It's not really changing the number of people in total who will end up getting the disease, but of course, there is some science to the fact that the longer it is before more people get it, the less virulent it is, right? It is more survivable the longer it's been around. At least that's the way most viruses work. Anyway, moving along here, let's go back to the next example. Sketch the following graph, 3 to the power of x. Okay, what's different about this from the last one? Well, the last one was 2 to the power of x. But notice it still goes through this point right here, because anything to the power of 0 is 1. And then 3 to the power of 1 is 3. 3 to the power of 2 is 9, so it's actually curving up rather sharply. And then 3 to the power of negative 1 is a third, and then a 9th, and then a 27th. So it's actually the exact same shape, but you'd say steeper. And then what about 1/2 to the power of x? Well, again, anything to the power of 0 is 1, so it still goes through there. But what's 1/2 to the power of 1? A half. What's a half squared? A quarter, an eighth. So we are heading towards our asymptote that way. And then what's 1/2 to the power of negative 1? Any ideas? 2. So it's actually going up. And then 1/2 to the power of negative 2 is 4. So that's why this graph is backwards. Looks like the mirror image of y equals 2 to the power of x. And once again, I can kind of show you that just by quickly going to my Desmos graph. As I change, a is, let's see, let's go back on that. Oh, that's not what I want to do. There we go. Let's fix that. There we go. Go backspace and make a 1, or even better, let's make a slider. Let's make a go from 0 to 5. And play in steps. We'll go in steps up, I don't know, 0.1. There we go. Play. Look what happens when x gets bigger. It goes more, and then it gets smaller. And look what happens when it goes past 1. That's a little faster than I wanted it to go. Slow down! Okay, but you get the idea. So when it is bigger, right, the bigger the number is, the steeper the graph. By the time I get to a to the power of 10, geez, I mean, just look at how fast that shoots up. But when I get one that is, well, again, at 1, of course, it's a flat line. But what happens when it gets to, say, 0.9? Aha, now it curves the other way. How about 0.8, 0.7, 0.6, 0.5? I think you get the idea. So there we go. You'll notice 7.1 doesn't actually have any homework. So you don't actually have to do an assignment for 7.1. And that's it. That's the whole lesson. All right, you can get working on your quiz now. I'll stop the video. Thanks for watching, everybody. Guys at home, feel free to tune out and get going on homework and stuff.